And we said if you were to draw the switching characteristics of that, so this was V in versus V out, we had this curve. Let's make it blue here just for look like this, right?
Yeah.
Something like that. And then we drew this line here through, and we said, oh, if you just take the slope of V in versus V out, and we said, this is the switching threshold between them, right?
Yes.
And let's say this was VDD. En equals VDD. In ideal case, this would be at VDD over 2.
Okay.
If the PMOS could give the same current as the NMOS, when, like, let's say VDD, like when we were at 0.5 volts and this was 1.0 volts, then we'd have an equal amount of, if they both had the same strength, they would have equal amount of current. And if they had equal amount of current, this would just sit at the middle at 0.5. So that would be a VDD over 2, which would be equal to 0.5 volts, right?
Okay.
Now, what happens if we make, let's say we make the W over, let's say the ratio of mobilities was 3 to 1. And so this W was equal to 3, and this W was equal to 1, and they had the same length. And that gave us exactly this situation. And then we increase this to say 3.2 W. Now this has a little more current. It can provide a little more current than this.
Okay.
So for the same V in, we would get a higher V out. Okay. So for the same V in, now we're at a new curve that has a higher V out. And so what that looks like is we've moved it over here so that the V out is a little bit, it's basically the curve is moved to the right because the P is a little bit stronger than the N. But so this switching threshold moves left or right, depending on the ratio of these transistors.
But the conflicting part for me is to think like, okay, so if the width is inversely proportional to the resistance, then you are increasing the current, but you are also decreasing the resistance. So how are you getting more voltage?
Well, think about this. If I drew this as a resistor, like say this PMOS was a resistor, and let's say it was 1 kilo ohm, right? And I have a voltage drop across this, right? This VR, whatever this. And then I make the W, which goes up, but then the K goes down, like maybe it's 900 ohms. And now I can get more current going through here for the same voltage at the output. Or you can think about it, more current forces this voltage up a bit.
Okay, but wouldn't the increase in current and decrease and the
originally I had these both 1K. They were both 1K, and we were sitting at 0.5 volts. And now I made this 900 ohms. Guess what? This voltage is going to go up. We have a simple resistive divider here.
Oh, okay, I see now.
You see that?
Yeah, yeah,
good?
yeah.
You all good?
Yeah, you just okay. You're changing one, no, the other. Okay.
Okay. Let's go back here.